Good day, everybody, and you're most welcome to today's session of the CNPS, which is one of our Saturday technical sessions. My name is Ian Cowan, and today is the 14th of February, 2026. Yes, St. Valentine's Day. And do you know that there are relics of the martyred Roman saint Valentine in the Carmelite Church of Whitefriars Street, which is not more than 3 miles from where I sit at present, and the relics are said to contain his heart. So let's hope there'll be some affable interchange between us dissidents. Right. So enough of that. I might just get the bit of housekeeping or procedures out of the way before we discuss today's technical session. And as you probably know from previous announcements, the CNPS has again, as it did last year, launched a fundraising endeavor to make up the shortfall between the membership dues, the income derived therefrom, and the actual operating costs. I think almost 50% has been actually achieved. The fundraising endeavor will be running for another 2 months or so, I think until the end of April. So I'll just play a little video. It only takes 1 minute just to remind people of that. And I think the CNPS would, of course, like to renew its thanks to those who have already contributed. So I'll be back after this video. Media assets, how do I get the video? It's the president, David Hilster, speaking.
Hello, everyone. I am David D. Hilster, president of the CNPS, and this is our annual fund drive. First, I want to thank all of those who have been paying their annual and monthly memberships through our automatic membership system. It is greatly appreciated. Since 1994, this group has been pioneering support for critical thinkers outside of mainstream science, and we continue to do so through our virtual presence, through our Saturday morning live streams, and our website discussions. Since last year, we have cut our expenses down to something reasonable for our current membership. In 2026, we hope to implement the Discourse Discussion Group as our primary discussion software. Our current website system, in my opinion, is not ideal. We hope to change that. To donate, you can go to fund.naturalphilosophy.org and donate whatever amount that works for you. Your contributions are greatly appreciated. Thank you.
Very, very well. We're back now. Right. Today we're very happy to have Vladimir Netchitailo back to speak to us. I think this will be his 10th presentation. We were just reminding each other of the numbers. He gave 8 consecutive presentations almost 2 years ago on his very extensive theories, WUM and so on. And he's spoken to us before, more recently on the Saturday session. And today, very kindly, will be the first time he's spoken to us on the Saturday session, certainly this year. But he's produced a new extension of his ideas, and actually he's succeeded in getting it accepted for publication. It's concerned with Hubble tension. So we're all talking about the buzzword Hubble tension, where there's a disparity in the evaluation of the Hubble constant from different means, from the normal sort of extrapolation of data and analyzing using the equations of the Hubble law and so on, and also evaluating such a value, such a parameter from the conventional theories of the Big Bang and going back to the early universe and expansion and all these ideas which the mainstream promulgate every single day, and which most dissidents, including myself, I might say, question. Okay, so what Vladimir is looking at present is evidence for what he terms a patchwork quilt structure of the visible world in world universe cosmology. World universe cosmology is his model, as far as I can see, his basic theory, and I think he's talking about maybe a non-unified structure, but he'll be telling you more about that. So, again, just to tell you how this is in contradistinction to conventional views, such as the Big Bang model, we say that unlike the Big Bang model, which assumes a practically infinite, homogeneous and isotropic universe, expanding from an initial singularity. So world universe cosmology envisions a three-dimensional, finite, boundless, observable world as a patchwork quilt composed of approximately greater than or equal to 1,000 luminous superclusters. 10 to the power of 3, I think that's correct, yes. That formed independently in different regions and at different cosmological times. So that seems quite interesting and actually very specific if he's talking about numbers like that. Just pardon me, I'm just looking to see if there are any emergent comments coming in. They just basically... So as I mentioned comments, what we'll do as normal is very shortly I'm going to disappear and hand the floor over to Vladimir. So he's already got his slides up and at his command, I can just bring them up and he has then complete control of them. He can go through them. And yes, okay. So as I say, this is a more formal structure of lecture than the normal conversational systems we have. But it is possible to interrupt the speaker in an emergency. So normally we would give him about an hour to speak. Now the hour isn't fixed to the minute or the second. So if he finishes after 50 minutes, we'll have a longer time for discussion. If he wants to go for an hour and 15 minutes, that's fine as well. It's a bonus in a way because we get more information. But we'll allow that. However, it is possible. Don't feel constrained. If you are really concerned about something he said, which cannot wait for the discussion after his lecture, just put a note in there. Ian, would you mind? And I'm sure Vladimir would not get angry if we did stop him. But that's in extremis. Normally, we'll give him an uninterrupted session. And then at the end, we'll deal with both questions coming in on the social media. So we have people coming in through the Facebook and YouTube links, and they're putting questions. And again, as usual, I just remind you, a lot of the social media people are engaging in conversation just between themselves, and that's fine. But I could miss something. You might just be going off at a tangent or saying something about the weather today. So just say question for Vladimir or Ian, please note this so I don't miss it. And when we've dealt with those, we'll then deal with our interchange with people in the green room. Now, I see it's a number of people come in. And actually, sometimes some people prefer to follow the lecture through the social media and then at the end come into the green room. So I wouldn't be at all surprised if we get more people into the green room and there'll be an opportunity to talk. And some of the teething problems we've had with media, including myself, I had an old system which was giving teething problems. Well, my system and those of one or two other participants in the green room have been resolved, I'm glad to say. So there shouldn't be media problems, I hope. Okay, so that's 10 minutes of introduction. So Vladimir, good day again. You're very, very welcome. Thank you.
Thank you so much for introduction. I'm ready to start my presentation.
So what I'm going to do, and you know this already, but just to remind people, I'm going to go away. So it'll appear that I've left. But if you need me, just call me. I might take a second to come back because I have to bring myself up again. And just before I leave, do you want your slides up yet, or will you give me the prompt to put them up?
No, I will do it. It's not slides, it's a text. I will switch it.
No, but you
Okay.
can advance them, but I have to put them up. So I can put them up now.
I can do myself, no problem.
No, you won't be able to put them up. I don't think so. I have to put them up. So they're up now.
Okay.
And I'll disappear. You have complete control now, until you cease. But if you need me, I'll come back. So the floor is all yours, Vladimir.
Okay. Thank you so much. Let me do, oh my goodness, the full screen. Oh, it doesn't want to work. One sec. Why it does? Okay, it's much better. But it doesn't work. I cannot move it. Why? Okay.
Sorry, I'm coming back. So I actually introduced the full screen there, but you should be able to
let me do myself. I have another way to go.
Okay.
Let's go from the beginning, because for some reasons it doesn't want to move. I don't know why. Oh, this is exactly my point. Can you see
it? It seems fine now. Yes, it's excellent. Thank you.
Okay, slightly smaller size. Oh no. One sec. I will accommodate it for the full page. Okay, good. The persistent discrepancy between measurements of the Hubble constant, the fundamental parameter describing the expansion rate of the universe, has become known as the Hubble tension. Observational determinations of H0 derived from different methodologies and distance ladders disagree by amounts far exceeding their quoted uncertainties, suggesting that the standard cosmological framework may be incomplete. In this presentation, we examine the large-scale macrostructures of the world, superclusters and galaxies, and analyze their origin and evolution within the hypersphere world-universe cosmology, a proposed transformative new cosmology. Unlike the Big Bang model, which assumes a practically infinite, homogeneous, and isotropic universe expanding from initial singularity, WC envisions a three-dimensional, finite, boundless, observable world as a patchwork quilt composed of about 1,000 major luminous superclusters and formed independently in different regions and at different cosmological epochs. While the cosmic medium of the world in WC remains homogeneous and isotropic, the spatial distribution of macro objects is inherently inhomogeneous, anisotropic, and temporally non-simultaneous. We show that this intrinsic patchwork quilt structure naturally accounts for the observed variations in H0, offering a compelling explanation for the Hubble tension within the WC framework. Introduction. The workshop Tensions between the early and the late universe was held at the Kavli Institute for Theoretical Physics on July 15-17, 2019, to access the growing evidence for discrepancies in key cosmological measurements, most notably the value of the Hubble constant, and to examine recently proposed ideas aimed at resolving this tension. During the workshop, multiple new observational determinations of the Hubble constant were presented using a variety of independent probes, including Cepheid variables, strong lensing time delays, and others. Importantly, the emerging discrepancies do not appear to depend on any single data set or research group. In their summary article, tensions between the early and the late universe were the true and Rees emphasize that while the standard cosmological model successfully accounts for observations spanning a wide range of epochs from primordial nucleosynthesis to the present-day accelerated expansion, it is not guaranteed to remain valid as the precision of cosmological measurements continues to improve. The growing mismatch between early and late universe determinations of cosmological parameters, particularly the Hubble constant, may signal the need to extend the standard model and could point toward new physics. It's exactly what is meaning of my presentation. The results of measurements of the Hubble constant obtained between 1994 and 2025 show that the values of H0 vary substantially depending on the methodology used. The disagreement between the measurements, often far exceeding the quoted uncertainties, clearly illustrates the severity of the problem. The average values of H0 span a broad range from 66.6 to 76.9 kilometers per second per megaparsec, with 21 measurements lying between 66.6 and 68.76, and 30 measurements between 69.32 up to 76.9 kilometers per second per megaparsec. This persistent and statistically significant inconsistency is known as the Hubble tension. Macrostructures of the visible world. The Laniakea supercluster is the vast galaxy supercluster that contains the Milky Way and roughly 100,000 neighboring galaxies. It's presented on Figure 1. It is one of the largest known major superclusters with an estimated binding mass of about 10 to the power 17 solar mass. Nearby major superclusters include the Shapley, Hercules, Coma, and Perseus Pisces superclusters. The distance from Milky Way to the center of Laniakea supercluster is approximately 250 million light years. We stress that this patchwork quilt structure of visible world was revealed Tully et al. With his team in 2014. It is experimental results. It's astronomy. It's not theoretical model. It's astronomy picture built by Tully with his team. A key structural feature of Laniakea is the Great Attractor, a massive region acting as a gravitational focal point for the galaxies within Laniakea. Also not a single object, it represents a dense concentration of galaxies and dark matter located behind the zone of avoidance, making direct optical observation difficult. Nevertheless, its gravitational influence is unmistakable. Key details. Laniakea, a vast major supercluster of about 100,000 galaxies, including Milky Way. The name Laniakea means immense heaven in Hawaiian. Tully works in Hawaii, that's why maybe named immense Hawaiian. Great Attractor, the dynamical center of Laniakea, containing a mass of order 10 to the power 16 solar mass, shaping the motion and flow of galaxies within the supercluster. Our location, the Milky Way, as I showed, sits near the outskirts of Laniakea within the Virgo supercluster and is moving toward the Great Attractor. The influence of the Great Attractor is inferred from peculiar velocities of galaxies, systematic deviations from a pure Hubble flow. Although most galaxies are redshifted overall, consistent with cosmic expansion, the variations in these redshifts are large and coherent enough to reveal a net flow toward the attractor. These peculiar velocities range from roughly plus 700 to minus 700 kilometers per second, depending on the galaxy's angular position relative to the great attractor. The attractor itself is moving toward the sharply supercluster. Also, the center of Laniakea has a redshift 0.0708. This does not imply that it is receding from Milky Way. Instead, the Milky Way is moving within the gravitational potential of the supercluster. Some galaxies in Laniakea are moving toward Milky Way, while others move away. Their redshifts, therefore, depend on their location and motion within Laniakea. The situation becomes even more complex for galaxies associated with neighboring superclusters. It is worth noting that more than 8,300 blue-shifted galaxies beyond the local group were known by 2009. Explaining these observations consistently within standard cosmology remains challenging. On Figure 2, presented the picture, the combination of all these filaments, galaxy filaments, coming from different superclusters and interacted between them. There is some connection between them. It is a representation of structure and flows due to mass within these parameters. According to WC, the Hubble parameter should be determined exclusively from the cosmic microwave background data, which reflects the properties of the homogeneous and isotropic cosmic medium. The value calculated in 2013, 68.73 kilometers per second per megaparsec, is in excellent agreement with the 2021 determination based solely on cosmic microwave background data, 68.7 plus minus 1.3 kilometers per second per megaparsec. I want to demonstrate that it's calculated in 2013, and this picture of the visible in universe was revealed by Tully in 2014, practically at the same time. The mass to light ratio in the Virgo supercluster is roughly 300 times the solar ratio, and similar values are found in other superclusters. Already in 1933, Zwicky measured the velocity dispersion in the Comet supercluster and derived a ratio of about 500, concluding that dark matter must exceed luminous matter by a large factor. Such high ratios remain fundamental evidence for significant amounts of dark matter in the universe. We emphasize that about 100,000 galaxies within Laniakea are orbiting the center of this supercluster, the attractor. They are bound members of Laniakea and didn't originate from a single initial singularity in the sense implied by the standard model. Neighboring superclusters show analogous structure, as I showed you on Figure 2. Together, they indicate that the visible world is, in fact, patchwork quilt of more than 1,000 luminous superclusters. According to Tully et al., galaxies congregate in clusters and along filaments and are missing from large regions referred to as voids. These structures are seen in maps derived from spectroscopic surveys that reveal networks of structure that are interconnected with no clear boundaries. Experimentally, it's absolutely right, but he follows the standard cosmological models. That's why he is going from bottom extrasolar systems galaxy to supercluster arrangements. In my model, vice versa. Wang et al. Made a great discovery. Most cosmological structures in the universe spin. All those structures in the universe form on a wide variety of scales, from small dwarf galaxies to large superclusters. The generation of angular momentum across these scales is poorly understood. We have investigated the possibility that filaments of galaxies, cylindrical tendrils of matter, hundreds of millions of light years across, are themselves spinning. We have found that these objects too display motion consistent with rotation, making them the largest objects known to have angular momentum. These results signify the angular momentum can be generated on unprecedented scales, more than 100 million light years wide, spinning. Lopez reported about the discovery of a giant, almost symmetrical arc of galaxies, the giant arc, spanning 3.3 billion light years at a distance of more than 9.2 billion light years away, that is difficult to explain in current models of the universe. This new discovery of giant arc adds to an accumulating set of challenges to the cosmological principle. Cosmological principle, everybody knows, homogeneous and isotropic universe overall in average. WC. These latest observations of the world can be explained in frames of the developed WC only. Galaxies do not congregate in clusters and along filaments. On the contrary, cosmic web, that is networks of structures that are interconnected with no clear boundaries, is the result of the explosive volcanic rotational fission of universe-created matter cores of neighboring major superclusters. Generation of angular momentum across their scales provide UC matter cores of superclusters through the explosive volcanic rotational fission. Spinning cylindrical tendrils of matter, hundreds of millions of light years across, are the result of spiral jets of galaxies generated by UC matter cores of superclusters with internal rotation. The giant arc is the result of the intersection of the galaxy's jets generated by the neighboring UC matter cores of superclusters. 13.77 billion years ago, when the Laniakea supercluster emerged, the estimated number of UC matter major supercluster cores in the world was around 1,000. It is unlikely that all of them gave birth to luminous superclusters at the same cosmological time, being far away from each other. The three-dimensional, finite, boundless, visible world presents a patchwork quilt of different major luminous superclusters, which emerged at different cosmological epochs. The main conjecture of Big Bang model, projecting galaxy trajectories backwards in time, means that they converge to the initial singularity at t equals 0, that is an infinite energy density state, is wrong, because all galaxies are gravitationally bound with their major superclusters, as I demonstrated you on figure 1 and figure 2. Explosive volcanic rotational fission. One sec, I will do some accommodation, sorry. Explosive volcanic rotational fission model. In our previous articles, we followed the standard paradigm of dark matter, which is not appropriate within the framework of WC. Instead, WC posits that the world consists solely of particles of ordinary matter, protons, electrons, photons, and neutrinos, and a distant class of particles created by the eternal universe itself. These particles, called universe-created particles, constitute a new type of universe-created matter. In 2024, 2 years ago, we introduced the term UC particles, which possess the following key characteristics. They can be fermions or bosons. Their rest energies are given in Table 1. from 1.3 tera-electron volt up to 5.3 micro-electron volt, 18 orders of magnitude. They interact via the weak interaction. They undergo self-annihilation similar to Majorana fermions. Ordinary particles are produced as the byproducts of UC particle self-annihilation. These frameworks allows an easy conceptual transition from traditional dark D matter to universe-created UC matter as used in WC. Table 1 presents universe-created particles proposed in our world universe cosmology. In this table, the basic energy unit E naught equals Hc over A, about 70 mega-electron volts, where H is the Planck constant, C is the gravitodynamic constant, A is the basic length unit, and alpha is the dimensionless Rydberg constant. Optical invisibility versus multi-wavelengths observability. These universe-created particles are dark, only in the narrow sense that they are optically invisible when observed through telescopes using visible light. However, modern astronomy spans wavelengths from radio to gamma rays, and it is in this broader constant UC matter is not dark at all. The diversity of non-optical observations support this view. Cygnus X1, revealed in 1971, the first known X-ray binary, is a persistent bright source of hot X-rays up to 60 kiloelectron volts. In 2000, Minchin et al. Discovered the binary galaxy system Virgo HI-21-NGC 4254, exhibiting strong 21 centimeter radio emission. Two origins of radiation in the world. WC distinguishes the radiation of ordinary matter from that of universe-created matter. Ordinary baryonic matter radiates electromagnetic waves ranging from radio waves to X-rays, primarily through the dynamics of electrons outside atomic nuclei. Universe-created matter radiates gamma rays emitted by nuclei as a result of UC particle self-annihilation. Their rest energies span 18 orders of magnitude, as I demonstrated you in table 1, producing a wide variety of gamma ray structures. Purpose of the multi-component UC matter system. This multi-component UC matter system was introduced to explain the diversity of very high energy gamma ray sources observed in the visible world. The diversity of UC matter cores in macro objects, superclusters, galaxies, and extrasolar system, which in WC function as fermion compact objects and self-annihilating reactors. Because UC carry no electric charge, their masses cannot be directly measured through mass spectrometry. They can only be detected indirectly via their annihilation signatures. Observable signatures of UC particle self-annihilation. Expected rest energies from UC particle self-annihilation, including 1.3 tera-electron volts, 9.6 giga-electron volts, 70 mega-electron volts, 340 kilo-electron volts, 3.7 kilo-electron volts, and 0.02 electron volts. These energies appear in the spectra of the diffuse gamma-ray background, emissions from various macro objects throughout the world. We associate these observed gamma-ray features with the internal structure of macro objects, their nuclei and shell compositions. Different combinations of UC particles naturally yield a corresponding diversity of gamma ray lines. Thus, within WC, the observed richness of very high energy gamma ray sources receives a coherent and natural explanation. It is worth noting that the rest energy values of UC particles were selected in WC in 2013 on the basis of experimental results from gamma ray astronomy. It's a very important point that I started from experiments and I found these lines, and then I put the rest energies for dark matter and now UC matter particles. Remarkably, these values are well approximated by the relation energy equals alpha in power n E naught, where the integer index n takes the discrete values from n minus 2 to n equals 6, as I showed in table 1. Macro-object shell model. In WC, the macrostructures of the world, superclusters, galaxies, and extrasolar system contain nuclei composed of UC fermions surrounded by nested shells made of UC matter and baryonic matter. These shells are arranged concentrically like a Russian doll. Their structure follows a simple principle. The lighter the particle, the larger the radius, and the greater the mass of its shell. The heaviest particles occupy the innermost shells, the lightest form the outermost layers. A proposed weak interaction among UC particles maintains the structural integrity of all shells. Table 2 summarizes the parameters of macro-object cores modeled as three-dimensional viscous fluid spheres whose high effective viscosity allows them to behave as solid-state objects. In Table 2, parameters of macro-object cores composed at different fermions presented. Shell composition and macro-object types. Based on the calculated parameters, WC predicts the following internal structures of macro objects. Cores of stars in extrasolar system consist of UC fermion 1 and or UC fermion 2 nuclei. Take a look. The maximum mass practically equal to solar mass for both fermions. Galactic cores contain UC fermion 1, UC fermion 2 nuclei with shells of UC fermion 3 and or electron positron plus. You can take a look on the numbers for the masses. It's about million solar mass or even up to 10, I don't know, it's up to 10 giga mega electron volt. Cores of superclasses contain UC fermion, UC fermion 2 nuclei surrounded by successive shells UCF3 and UCF4. You can take a look on the numbers of the masses of superclasses. It might be up to 10 to the power 19 solar mass. Let me remind you, the mass of Laniakea is about 10 to the power 16, 17. Okay. Accordingly, galactic cores are interpreted in WC as supermassive compact objects composed of UC fermion 1 and 2, surrounded by an outer UC fermion 3 shells. Their maximum mass, derived from the parameters listed in Table 2, is approximately 6 to the multiplied to the 10 to the power 10 solar mass. Take a look on this line. It's exactly the calculated number of the mass. Remarkably, this theoretical upper limit is consistent with observational data for the most massive known dark compact object, the central mass of the quasar Ton 618. They calculated this number 6.6 up multiplied 10 to the power 10 solar mass. Take a look how close their so-named black hole is equal to the mass of our supermassive compact object. A major recent observational milestone highlighted the biggest breakthroughs in physics 2025 is the work titled A Direct Black Hole Mass Measurement in a Little Red Dot at the Epoch of Reionization by Judas Bali et al. In the abstract of their articles, the authors wrote, "We report the direct dynamical black hole mass measurement in a strongly lensed little red dot at redshift 7.04. The combination of lensing with deep spectroscopic data reveals a rotation curve that can be well explained by Keplerian rotation around a point mass of 50 million solar masses, consistent with the virial black hole mass estimate from the Balmer lines. Such a naked black hole, together with its near pristine environment, indicates that this LRD is a massive black hole seed caught in its earliest accretion phase. Can you believe it? It's a naked black hole. You have already so-named naked black hole. There is nothing around because, according to my model, it should be, first of all, some kind of fission, and only then you can generate some galaxies around it. It's exactly compact, supermass compact object with 50 million solar masses, as we know now for sure. Its center, it will be future center of the galaxies around this center. Within the framework of WC, this object is not a black hole. Instead, it is naturally interpreted as a rotating supermassive compact object composed of UC fermion 1 and 2, and surrounded by an outer UC fermion 3 shell observed prior to detonation during its accretion phase. It is essential to emphasize that WC contains no black holes. Observational phenomena commonly attributed to black holes are instead interpreted as a manifestations of UC matter-based supermassive compact objects governed by the physical principles of WC. Empirical confirmation of WC predictions. It was the prediction 2013. The 2020 Nobel Prize in Physics awarded to Gensel Gas for the discovery of supermassive compact object at the center of the Milky Way provides strong observational support for a key prediction of WC first stated in 2013. Macro objects of the world have cores made up of the discussed dark matter particles, other particles, including the UC matter particles and baryonic matter, form shells surrounding the cores. Let's start with the most principal point of my model, angular momentum. The angular momentum problem is one of the most critical unresolved issues in the standard cosmological model. Any viable theory of cosmic evolution must explain the origin and conservation of angular momentum across all scales, as I named before. To the best of our knowledge, WC is the only existing cosmological model fully consistent with the law of conservation of angular momentum. To satisfy this requirement, a cosmological model must answer the following fundamental questions. How did galaxies and extrasolar systems acquire their substantial orbital and rotational angular momentum? How did the Milky Way galaxy give birth to numerous extrasolar systems at different cosmological times? In Milky Way is approximately If Milky Way is approximately as old as the world itself, what is the origin of its enormous orbital and rotational angular momentum? A discussion of the beginning of Milky Way is required. Why is the oldest known star in Milky Way, Methuselah, nearly as old as the universe? The solar system formed 4.57 billion years ago. What is the origin of its rotational and orbital angular momentum? This requires addressing the beginning of the solar system. Rotational fission at the source of angular momentum. In our view, there is only one physical mechanism capable of imparting angular momentum to macro objects: rotational fission of overspinning prime objects whose equatorial surface velocities exceed their escape velocity. This is a definition. According to the fission model, a prime object transfers part of its rotational angular momentum to the orbital and rotational angular momentum of the objects formed from it. Consequently, the rotational angular momentum of the prime object must exceed the total orbital angular momentum of its satellite. Prime objects in WC and the dark epoch. Within WC, prime objects are UC matter cores of superclusters, which must accumulate enormous angular momentum before the birth of the luminous world. This requires a sufficiently long preparatory phase. We designate this interval as the dark epoch, and it forms the basis of the new cosmology in WC. Dark invisible epoch, lasting from the beginning of the world 14.22 billion years ago for 0.45 billion, when only UC matter macro objects exist. About 500 million years before we have our luminous epoch, beginning 13.77 billion years ago for the Laniakea supercluster, and continuing to the present, during which luminous macro objects emerged through the explosive volcanic rotational fission of supercluster UC matter cores and through UC particle self-annihilation. Transfer of angular momentum in WC. The UC matter cores of major superclusters are the primary engines of the visible world. During the dark epoch, they accumulated vast masses and rotational angular momentum, which were subsequently transferred to the UC matter cores of galaxies during their rotational fission. Observationally, the majority of galaxies are these galaxies, strongly suggesting a rotationally driven formation mechanism consistent with rotational fission. The UC matter core of the Milky Way was created 13.77 billion years ago as a direct result of rotational fission of the Virgo supercluster's UC matter core. UC matter cores of macro objects, extrasolar systems, planets, and moons formed through repeated rotational fissions of galactic UC matter cores at different cosmological times. For example, 4.57 billion years ago for the solar system within Milky Way. Top-down formation of structure in WC. In WC, macro objects form in a hierarchical top-down sequence. Superclusters, galaxies, extrasolar systems with planets and moons. This structure arises naturally from cascading rotational fissions of increasingly smaller UC matter cores, propagating the transfer and conservation of angular momentum throughout the world. Formation of macrostructures. Cores of all macro objects share a common set of fundamental properties. Core shell structure. The nuclei of all macro objects are composed of universe-created fermions. These nuclei are surrounded by concentric shells containing universe-created matter and baryonic matter. Continuous UC particles absorption and matter production. Universe-created particles are continuously absorbed by the cores of all macro objects. Ordinary matter, comprising approximately 7.2% of total matter, 4.8% in the cosmic medium, and 2.4% in macro objects, is produced as a product of UC particle self-annihilation and is continuously re-emitted by macro objects' cores. Consequently, macro object cores function as self-annihilating reactors fueled by UC particles. All chemical elements, compositions, and radiative outputs are generated in situ through UC particle self-annihilation within self-annihilating reactors. Time evolution of nuclei and shells. Both nuclei and shells grow with the absolute cosmological time tau, size proportionally to root square of tau, mass proportional to tau in power 1.5, and rotational angular momentum proportional to tau squared. Growth continues until a critical stability threshold is reached, at which point the system undergoes detonation. Detonation and satellite formation. Overspinning UC matter cores. At the critical point, overspinning UC matter cores undergo detonation. This process releases satellite cores together with their orbital and rotational angular momentum. Nature of detonation. The detonation does not destroy the parent core. Instead, it manifests as a gravitational hyperflare, ejecting satellite UC matter cores while preserving the integrity of the prime object. Origin of diversity. The size, mass, composition, and angular momentum of satellite UC matter cores depend on local density fluctuations at the edge of the prime UC matter core and the cohesion properties of its outer shell. Volcanic ejection mechanism. Satellite UC matter cores are expelled through localized eruptive regions, volcanoes, on the surfaces of the prime UC matter cores. These eruptions occur recurrently and drive hierarchical structure formation. Within WC, this explosive process in prime UC matter cores is termed a gravitational burst by analogy with a gamma ray burst. In the WC framework, such gravitational burst events may constitute the physical origin of the gravitational waves observed experimentally. Repeating gravitational bursts. In the WC framework, recurrent gravitational bursts arise naturally through the following cycle. During each gravitational burst, a prime UC matter core loses a small fraction of its mass, but a large fraction of its rotational angular momentum. After the gravitational burst, the core resumes absorbing UC particles in accordance with these equations: mass proportional to tau in power 1.5, and rotational angular momentum proportional to tau squared, until the next stability threshold is reached and another gravitational burst occurs. This cyclic process explains why satellite UC matter cores rotate about their own axis, and satellites orbit the UC matter cores of their prime objects. X3a is a recently discovered baby star located in the immediate vicinity of Sagittarius A. Unbelievable. Age of this baby star, extremely young, estimated at only tens of thousands of years, making it younger than the human species. Mass, a giant among stars. It is approximately 15 times the mass of the sun. Size, roughly 10 times larger than the sun. Classification, it is categorized as a high mass young stellar object. Even for me, it's unbelievable. I knew about million years, but now it's a few 10,000s. During human pieces, they lived already on the earth. It's unbelievable. Astronomy has done great job. It's so great observation, so good. I have no words. Afterglow phenomenon. General afterglow. The afterglow of gravitational burst is produced by post-detonation processes within the nuclear and shells of UC matter cores. Extrasolar systems. In extrasolar system, the stellar wind is the afterglow of a star's UC matter core detonation. The core continues to absorb UC particles, increasing its mass proportional to tau in power 1.5, while excess rotational angular momentum is shed through wind particles. Solar system. The solar wind represents the afterglow of the solar UC matter core detonation 4.57 billion years ago, continuously forming the heliosphere solar bubble. Galaxies. In galaxies, galactic winds are the afterglow of repeated galactic UC matter core detonations. In the Milky Way, this process continuously sustains the two UC matter Fermi bubbles. They are dark in sense that we cannot see them. They have all the kind of gamma radiation from Fermi bubbles. I started my investigations from these Fermi bubbles from 1.3 tera-electron volt up to the down, up to 0.2 electron volt. All these lines of gamma radiation you can observe at the center of our Milky Way. Hubble tension explanation within WC. Observations show that the majority of galaxies in the universe are disk galaxies. For spiral galaxies, the side rotating toward the observer exhibits a slight blue shift, while the receding side exhibits a red shift. Consequently, a physically meaningful redshift can be defined only for the galactic center, not for the galaxy as a whole. It's a very important point. The measured redshift of the center of the Laniakea supercluster that equal 0.0708. This value doesn't imply the Laniakea is moving away from the Milky Way. On the contrary, it indicates that Milky Way is moving away from the center of Laniakea. Within Laniakea, some galaxies move toward Milky Way, while others recede from it, as I showed you on figure 1. Thus, the observed redshift of any particular galaxy depends strongly on its location and kinematics relative to Milky Way, rather than on universal recession velocity. The situation becomes even more complex when galaxies belong to different major superclusters, which in WC form at different cosmological times. In such cases, redshift is influenced not only by relative motion, but also by the epoch of formation of the host major supercluster. Time dependence of the Hubble parameter in WC. In WC, the Hubble parameter is not constant, but depends explicitly on cosmological time. H equals tau in power -1, inverse the equation. This implies that earlier epochs correspond to larger values of H. As a result, the value of the Hubble parameter must be inferred from observables that probe the cosmic medium itself rather than from properties of individual macro objects. The cosmic microwave background radiation uniquely satisfies this requirement as it reflects the properties of the homogeneous and isotropic cosmic medium. And Figure T presents recent determinations of H0 using cosmic microwave background data only. I want to show you how close all these four last measurements close to each other consistently. And this number I showed you before, the correlation between predicted number 68.7 in 2013 and it was measured in 2021. Origin of the Hubble tension. Within the WC framework, the Hubble tension arises naturally due to the following factors. All determinations of the Hubble constant are model dependent. The available statistics are insufficient to justify averaging disparate measurements into a single universal value. Hubble's law, as used in standard cosmology, is valid only within Big Bang model, where all galaxies originate from a single initial singularity, an assumption explicitly rejected by WC. Observational samples include galaxies belonging to different superclusters, which formed at different cosmological times. Since H inversely proportional to cosmological time, the value of H must in principle be different for each galaxy, depending on its distance and corresponding cosmological time. Averaging values of H across different masses and objects, as commonly done, has no physical justification in WC. The only physically meaningful determination of H is one based on cosmic microwave background observations. Big Bang model versus WC. Fundamental differences. The fundamental differences between Big Bang model and WC may be summarized as follows. Initial conditions. Big Bang model postulates an initial space-time singularity characterized by infinite energy density and extremely rapid expansion inflation. Within this framework, three-dimensional universe has no center of expansion. Still, nobody can show where is the center of initial singularity. WC proposes that a fluctuation within the eternal universe gave rise to a four-dimensional nucleus of the world, whose extrapolated initial radius equals the fundamental length unit about 10 to the minus 14 meters. The nucleus expands along the fourth spatial dimension at the speed c, interpreted as a gravitodynamic constant. This expansion produces a uniform stretching of its hyperspherical boundary, the world in WC, thereby accounting for cosmic expansion without invoking dark energy. You see, very important conclusion. There is stretching of the space, but there is no dark energy at all. You don't need it. It's a result of stretching. Structure of the world. Big Bang model, continuous stretching, assumes an almost infinite universe that is homogeneous and isotropic on large scales, centered conceptually around the initial singularity, and we don't know where. WC describes a finite, boundless world the hypersphere of the four-dimensional nucleus, constituting an absolute space. The visible world, which is a three-dimensional Hubble bubble, is a patchwork quilt composed of major luminous superclusters, about 1,000, that emerged in different regions of the world at different cosmological epochs. Medium of the world. Big Bang model commonly implies a vacuum-like state for the early universe, with matter and radiation emerging later. WC introduces a cosmic medium composed of protons, electrons, photons, neutrinos, and universe-created particles, previously referred as the dark matter particles. This medium is homogeneous and isotropic, whereas the distribution of macro objects is spatially inhomogeneous, anisotropic, and temporally non-simultaneous. The rejection of the luminiferous ether in 1905 marked a pivotal moment in classical physics. However, the cosmic medium of WC may be viewed as a modern, physically grounded revival of this concept, one that restores consistency to classical physics rather than undermining it. Conservation laws. Big Bang model does not explicitly address the physical mechanism responsible for the creation of angular momentum, nor does it embed angular momentum conservation as a foundation principle. WC uniquely provides a physical mechanism for the creation of angular momentum and is fully consistent with the fundamental law of its conservation. Macro objects formation. Big Bang model assumes hierarchical formation proceeding bottom up from extrasolar systems to galaxies and subsequently to superclusters. WC proposes a top-down formation scenario in which superclusters form first and subsequently fragment into galaxies and extrasolar systems. This process occurs via explosive volcanic rotational fission of overspinning major superclusters cores composed of UC particles. These cores were created by the eternal universe during the dark invisible epoch lasting approximately 0.45 billion years for Laniakea. Importantly, the formation of galaxies and extrasolar systems is not a completed process of the distant past, but it is ongoing, as I demonstrated with some fresh experimental results for Milky Way. Observational support for WC from supernova cosmology, the main supernova cosmology for dark energy. Progenitor HBRs in type Ia supernova. Strong empirical support for WC interpretation emerges from the recent series of papers entitled Strong Progenitor HBRs in Supernova Cosmology. These studies demonstrate that the luminosities of type supernova depend significantly on the age of their progenitor systems, introducing a previously unrecognized and substantial systematic bias into supernova-based cosmology. As summarized by Sun et al., supernova cosmology assumes that the luminosity standardization of type Ia supernova is invariant with progenitor age. However, direct measurements of host galaxies' ages reveal a highly significant 5.5 sigma correlation between standardized supernova magnitude and progenitor age. This bias is not corrected by the commonly used mass step method. After accounting for this effect, Supernova data aligned with Bower and cosmic microwave background results from DESI. Combining supernova, Bower, and cosmic microwave background reveals more than 9 sigma tension with the lambda S CDM model, suggesting a time-varying dark energy equation of state in a currently non-accelerated universe. I put my emotions to this conclusion. The currently non-accelerating, and there is a huge tension with lambda CDM model. Sorry. Resolution within world universe cosmology. Within the WC framework, these results are not indicative of a crisis, but rather a natural consequence of applying an inappropriate constant H framework to a universe, in which the expansion rate depends explicitly on cosmological time. WC predicts that measurements of the Hubble parameter derived from macro object-based observations, such as supernovae, will vary due to the spatial unhomogeneity, anisotropy, and temporal non-simultaneity of luminous structures. In contrast, measurements based on the cosmic microwave background, which probes the homogeneous and isotropic cosmic medium, yield a consistent and physically meaningful value of the expansion rate. Let me remind you that in cosmic medium, there is 2/3 of the total matter, 67% of the matter in the cosmic medium, and it was thrown away with dirty child. Conclusion. WC offers a fundamentally different physical picture of the world than Big Bang model, challenging long-standing assumptions and opening new perspectives in cosmology and classical physics. Within WC, the Hubble tension is not an anomaly, but a natural observational consequence of the patchwork quilt structure of the visible world. Whereas Big Bang model is largely mathematical in construction, WC is grounded in explicit physical mechanism and claims natural consistency with a growing body of modern observations, including those from GWCT. As famously stated, if it disagrees with experiment, it is wrong. It's exactly my point. I love this conclusion. Acknowledgements. I express deep gratitude to academician Prokhorov and Professor Manenko for their pivotal influence on my scientific path. Eternal thanks to my scientific father, Paul Dirac, whose visionary ideas inspired this work, and Tesla, another extraordinary genius. I extend my sincere thanks to Professor Korda for publishing my manuscript, it's already 41 of them, in the Journal of High Energy Physics, Gravitation, and Cosmology. I am also thankful to Ricker for valuable comments and suggestions that greatly enhance the clarity and scope of this model. Professor Korda published already 41, and the last one, based on this report, accepted for publication and will be published in April issue of this year. Thank you so much for your attention. I've finished my presentation. A little bit tired, sorry.
Well, thank you so much, Vladimir. And thank you for keeping to time. You've taken 5 minutes more than the hour, which is fine, which allowing for my 10 minutes of introduction just have occupied another 15 minutes. But there should be enough time to deal with some questions and discussion. By the way, Vladimir, would you prefer that I keep your slide, your visual slide up while we're talking, or shall I bring it down?
Let's bring it down, because I will try to answer all the questions based on this presentation, because to look for this sentence or all this stuff, it will not help.
Yeah, and we can bring it up again if
Yeah, yes. If it's a critical point, then we will open it. But right now, you can put it down.
okay. Well, perhaps we'll have a look at the questions in a second, and if I may be permitted the privilege of hosting this, just to make one or two comments. I'd like to draw to your attention what Vladimir already has done, indicating that the centrality of the angular momentum problem, the angular momentum conservation, and arriving at that, the centrality of that to his thesis, I think. Now, let me see what I have down here. Yeah, well, just a general point, and maybe one question before I get on. The general point is that it seems to me from your very extensive research that you're bringing in a sort of an explanation of this tension, which on the face of it might be considered a crisis, but you say it's not, because it can be dealt with by your modified system, and you're obviously bringing in the results of experimentation and observation all the time, a la Feynman, which is very, very important. So, however, I've done some complementary work, which I think is interesting. It's looking at it from another point of view, but maybe arriving at some results which are not diametrically opposed to your own. And I've suggested, on the contrary, maybe that the Hubble tension is a worrying point for conventional views. If you're getting these disparate parameters, it's almost a paradox. It throws some sort of doubt on the whole process of expanding universe from the Big Bang. But maybe in a way that's not diametrically opposed to your ideas. It's perhaps complementary. Do you see? I look at the Hubble parameter, the sort of linearity of what they consider velocity of recession and redshift, or maybe more fundamentally, the redshift distance. This linearity as being a major problem, and therefore there's no simple proportionality constant. By the way, may I just mention one other thing? It's maybe my last question. It might be related to this, Vladimir, but I think you said somewhere that you confirmed that the parameter of h naught varies with time, but that's also in conventional views. It's not just in your own theory. It is a function of time, isn't it?
Let me give you some comment. In my model, there is no redshift as the parameter at all. Because as I tried to show in my experimental results, not my experimental results, but my explanations of them, there is no meaning. Even for each galaxy, you have only the redshift for the center of the galaxy. But what about the rotation? How to take into account? It's not the overall galaxy. It is only center, you can name it. What is important? The variation in the redshifts so huge between different positions, different galaxies, and so on and so on. There is no meaning to compare with each other. That's why we don't need redshift as the parameter of a new cosmology. This is my main point. That's why combination of different experimental results and trying to find some correlation between them, it's a mathematical tricks sometimes, than the real physical parameter. As I told you, there is only one Hubble parameter based on the properties of cosmic medium. That's it. Cosmic medium, homogeneous, isotropic. You can measure the parameter. It's a physical parameter. And what is important, there is no variation even. I showed you for the last experimental results obtained for this parameter. They're so consistent. There is no question about any Hubble tension. There is a coincidence, strong coincidence between different groups with different measurements. No, man. We don't need redshift, blue shifted. As I told you, there are thousands and thousands blue shifted galaxies. What we're gonna do about it? I don't know what to do even with our neighbor galaxy.
The Andromeda, yes.
Andromeda, she is blue shifted. She is moving to us. It's against its standard model at all. And there is no explanation why it's moving to us. I mean to Milky Way, not us personally. That's why, please, it's the main objective of this presentation to tell, guys, redshift, it's convenient for your estimation of something, but it's not physical parameter in sense that you can reliably measure it, because all of these measurements model dependent. You have this model, that model, and according to this model, you are trying to do experimental result and to fix it to existing theoretical model. My point are absolutely different. To take a look on experimental results, find this, and then give your explanation, some equation, some calculated parameter. Totally different physical approaches. First of all, observation, experimental results, and only then go with your explanation.
All right. Well, there's one sort of supplementary point which has been raised by a question here. He said he's listened to some of your talks before, but he forgets how you arrive at the age of the universe, though it is very close to the age estimated by the Big Bang. I think 14.4 thousand million years or something is your own estimate. Could you give us simple?
According to Big Bang model, the age is 13.7778. That's it. Exactly. Luminous epoch is the beginning of Big Bang model.
But you have a figure of 14.4, don't you? And then there's a period before.
Yes. I showed you. I gave you additional 500 million years to do this dark epoch and to collect all the mass and angular momentum before explosion of this dark matter core, huge dark matter core, or you see matter core.
What is important? Come out of your equations, basically.
Yes, how I calculated the absolute age of the world, 14.22 billion years. According to my model, this age of the world calculated based on gravitational parameter only. Experimentally, we measure gravitational parameter on Earth, and then there is a combination of standard parameters, and based on this combination, you can calculate this absolute age of the world. There is no theoretical mathematical calculations. No, it's based on a experimentally measured gravitational parameter. If you need some reference, I don't know who asked this question. I can provide you with all of my.
Jerry.
Okay.
Okay. I'm just looking at, because a lot of this has been conversation. You've sort of prompted a lot of conversation, but there are not many questions. Okay.
It's usually too much.
Well, to be frank, I mean, you can read those yourself, Vladimir, but some people, maybe Jerry and others, have said, you've so much information there that it's hard to follow. Well, that's a compliment, actually, because you've done so much work that it's not a simple thing of imbibing.
That's why I read my presentation, because it's very difficult to take all of them at once. And it's only small part of my model, small part, believe me. This is the number 10 presentation at your CNPS session.
So,
and all of them different.
Would you recommend, or could you recommend to people who just have a general interest in what you're doing, maybe should they go to the journal where you've published these documents, or is there a website, or what would you recommend? Or maybe
I can give you the reference to all my manuscripts published by Journal of High Energy Physics, Gravitation, and Cosmology. It's already 42 articles I published. That's why
And I think that,
whatever you want, you can find in all this my list of publications.
yeah, I've done that. It's available basically freely, isn't it?
Yes, yes. It's freely, it's available, it's easy to see, no problem.
Okay, well,
And please ask me your questions by letters. With my pleasure, I will read your questions and I will try to do my best to answer them.
okay, well, that's a very generous invitation to all of us, actually, to contact Vladimir, and he will come back to you. Okay. There was something here just before we leave it. Okay. Referring to both of us, I think. I've lost it now, but it was somewhere here. Right. Okay. Well, I think perhaps there's some discussion about some new gentleman who's raising some new some new models as well. Yeah. Okay. Yeah, I think perhaps we should go to the green room now. Okay. Let me just check if I've missed anything at the very end. Okay. Here it is, yeah. Sure, Ian or Vlad could tell you when they get to your comment. I wasn't quite sure what comment that was. It might have been Shockwaves or somebody. But if I've missed anything, just put it up again. Although I'd like to, before we finish, and I might be repeating some of these sentiments, I always like to see that excellent presentation, Patriot 2.
Thank you.
I'm not sure who that is, but I would certainly.
It does matter.
Yeah, no, it is important. Okay.
It is important.
Because people are being confused, but on the other hand, you've made it what somebody has considered an excellent presentation. And the document is available, and you're very happy to answer any specific questions. I know that. So we leave that. But if I've missed that one question that you referred to me or Vladimir in, just post it again, and I'll come back. Now, the green room, we have some people in the green room, and I'd like to give them an opportunity to talk. So first of all, if anybody would like to come in now, he could raise his hand if he has any specific point. Because if not, I'll probably proposition you individually, because I think it's always very valuable to have a correspondence, chat between us in real time. Okay. You've gone to the trouble of coming in, and you've obviously listened to Vlad's talk. So I see. Let me see. I see who's here. I think Roger's helping in the background. James Keane is there, but I don't see his video. I don't know if he's there at the moment. Dennis Allen has come in, but he's both mute and his video is not on. So if he wants to switch those on, we can come back. And Carl Reef normally doesn't come in, but he's listening. Harry is there, Harry Ricker. So, okay. I don't know where Jim and Denny are. Let me see. Jim, you're not there, are you? No, he's probably disappeared.
Yeah, can you hear me?
Yeah, I don't see you, and I can hear you in the distance.
I was just listening.
Yeah, my apologies for imposing upon you, because you're always an interesting man to give us, if not you sometimes deal with specific things, but even an overall response. And I do see not just you, Jim, but all of you in the green room I don't think you've posted any private chat, which is fine. You don't have to. But so I'm just wondering, do you have any comments or anything? I know you yourself, as I have listened to a lot of Vladimir's talks. In fact, I think you've probably listened to the last 9 as well as I have. So have you anything additional or anything, comment, good, bad, or indifferent, or any question you want to put to Vlad?
Well, one thing that I think there is a certain tendency to take an observation and say that the observation caused the observation, and take angular momentum. The claim is made that we have this volcanic fission or whatever it is. That's the cause of angular momentum. But basically what's being said is that we've observed that angular momentum is, and that is the cause of angular momentum that we observe. In other words, we're running around in circles. So that's, and that makes it frustrating to listen to, because I think there's a tendency in many of Vlad's presentations to take an observation, in other words, a piece of data, and say that that's a cause of itself. And so that's one comment.
Yeah, okay. So do you remember we were talking about this hypotheses non fingo? I frame no hypotheses, Newton's ideas last week. Do you yeah. So I think you might be on a similar wavelength to me, Jim. But Vladimir, do you shy away from doing that, or do you think you might frame these hypotheses?
No. Let's stay with whatever it is. It's too much right now for all the people around. I don't want to put additional something. Tomorrow we have our group meeting. If you want to, Jim, we can talk about this tomorrow.
So what about ultimate causes? Just before we leave this point, suppose somebody came to you, journalist or something, and said, look, you've expressed a lot of equations and concepts and so on, and you've given ideas which are consistent with experimental results. But what are these would you attribute anything to the cause of these things? How would you answer that person?
What does it mean, cause? Cause is our world, the world surrounding. We have an observation, we are measuring some parameters, and model is model trying to explain observations, not from the sky, not from mathematics, from the observations. It's my approach. Even this, rest energies for universe created particles, I took from the gamma ray astronomy. You see what is important. I'm experimentalist by nature. I am not theoretician. And I tried all the time to go to experiments, to see the results, and then try to understand how to explain what is going on. What is the correlation between one experiment and another experiment? This is a model. It's the real standard physical, classical physics approach. You have your results, and you are trying to explain in a simple equations. By the way, today I didn't put any equation, any. It was only ideas, only approaches, only in words. Can you believe it? Today I didn't put any equation.
If we rewind
all the equations for classical physics.
If we rewind the tape, there were a lot of equations in there in terms of this equals that.
Well, simple equations, relating one variable to another.
The power of this times that.
Yeah, okay.
Or a raised to x power times another variable equals a certain quantity. So there were equations in there. So in other words, it's very difficult to really have a conversation because our presenter, I think, in my opinion, just contradicts himself. We don't need anyone else to contradict him, actually. Another problem is this the so-called conservation law, the conservation of angular momentum, and I know that apparently comes from Newton, but there's evidence that angular momentum is not conserved 100% and can switch between linear and angular momentum can occur. And Dennis Allen has presented results from Boeing and the satellites. There's a whole bunch of satellites up there which violates the law of the conservation of energy, or else they would fall to Earth. And so what happens is that in Vlad's presentations, it's one is left thinking, why is this not discussed? Or if he believes in the law of conservation of angular momentum, as he said in today, why does he reject this other data? I mean, it's sort of like in a vacuum. It's as if this other, he believes in observations, but all these observations that contradict his point of view are not discussed.
So things like inertial propulsion systems and so on, these are other things which, we really, they're quite interesting, Jim, but we could get into a conversation about those, but that would really be another lecture. I don't know if you want to say something. I think we should probably move on.
Well, that's the problem. You say another lecture, but a whole lot of time was spent in the paper that Vlad presented today, and thank you for presenting, Vlad, talking about angular momentum and its origin. But its origin was never given. It's just that there is angular momentum, and that's the origin of it. Now, in my binary mechanics cosmology, I give the origin of angular momentum based upon my work and the axioms or postulates that I provided. So why is this not mentioned, and why is this rejected?
Yeah, I think maybe, Jim, if I may just say this, that, and contradict me, Vladimir, if this is wrong, I think Vladimir's ideas would be more consonant with Newtonian ideas than yours would be. And maybe that's where this sort of apparent contradiction is coming in. But by the way, this person has said, I think that's wrong. He says the violations in the angular momentum or specific angular momentum comes from Kepler and Kepler's second law. These are fixed. I think he means, the variations in angular momentum, but not the contradiction of its conservation. So, so I think maybe in a nutshell so unless, Vladimir, you want to say anything else to Jim's point, we might leave that and come back to it at a later stage, because I see there are some other people who've come into the green room now.
Okay, sure. We can continue our talk. Many times we talked about, and he has his opinion, I have my opinion. We can continue our conversation tomorrow on our group.
Yeah, exactly. We have the private conversation, and we can do that, Jim.
Because there is nothing new he told me today. Nothing. It means
I mean, for my part, I have heard this idea before, and I think there is that's why I think we should maybe resist getting into a long conversation about this. But
let me only one comment to tell. Let me give you only one comment. First of all, I didn't reject any idea. I rejected Big Bang model only. It's not my goal today to have some introduction to all the existing models. Forget it. It's impossible. That's why, James, if you want to introduce your model, go. No problem with me at all. I'm trying to tell what I'm thinking about, what I've done.
I'll bring it down.
And that's it. But it doesn't mean that I rejected anybody else.
Yeah. Okay. Now, I just want to see, is there anybody else who wants to go? I see Nick has come in and he wishes to speak, and that's fine. Nick Percival, what do you have to say today?
Well, I will echo the previous thought of excellent presentation, Vladimir.
Thank you.
Also, I really like the fact that you focused on the conceptual rather than going deep into detailed math. With so much information, I think you have to deal with the conceptual until everyone's totally absorbed that. Um, I wasn't going to mention this, but since James Keen brought up non-conservation of angular momentum, which I agree with, but I kind of thought that missed the point, because you're already talking about where did all of this angular momentum and it's angular about different axes come from, and the only logical explanation whether it's conserved or not conserved is that there's not a single source of angular momentum, but multiple sources at different epochs. And so even conceding non-conservation, I think Vladimir's points are really strong points in favor of his theory. I did want to comment, maybe I missed the answer, but someone brought up the issue of your starting of the entire universe coincides pretty much with the Big Bang Theory, but the Big Bang Theory's computation of 13.77 billion years ago is based on one of the foundational ideas of Big Bang, which you dismiss. So that did strike me as something that I'd be interested in more fully understanding.
Yeah, I think Shockwave has brought up that point as well.
Yeah, I'm glad he brought it up. And then once he brought it up, I said, "Oh, man, that's an interesting point." Because the Big Bang figure of 13.77 billion years ago comes about from assuming that there is a single explosion and working backwards to that point. So I don't know.
So thank you very much for your comment, and thank you very much that 2 years ago you personally invited me to CNPS.
Yes.
Personally invited me to make my presentations. Personally recommended me to read them because it's too much for information in each presentation, and it's number 10 right now. Thank you very much for everything what you've done for promotion of my model. Thank you.
I think both Nick and Harry gave you a lot of pointers, which helped originally to bring you into our system.
Yes.
Yeah, I was also telling you have to get rid of the phrase dark matter.
Yeah, which you did.
Which you did,
the
yes.
universe created matter.
Nick was the first. Harry was the second one. He done great job for me. When he will tell me something, I will tell him what he's done to my model. Even definitions totally different. He asked so good questions to me that I had to think about, and I changed even definitions, notions of my model.
Yes, Harry is fantastic.
Yes,
again,
I appreciate your and his help for me to clarify my model.
Yes, thank you.
I'm just going to mention en passant that I think it was Shockwave said he's attributing the origin of angular momentum to Birkeland currents. So this is the whole electric universe business. Okay, it's a comment here. Okay, so Nick, anything else? No, that's fine. Thank you very much for your contribution.
Thank you.
So, and thank you, Vladimir, for dealing with us. Dennis Allen has now raised his hand. So, Denny, you're very welcome. What point or points would you like to make?
Well, excuse me. I've always shied away from cosmology because I feel that we don't know enough about physics to really be able to advance ideas in cosmology that could possibly be correct. James Keen mentioned angular momentum not being conserved and so on. Someone recently sent me an email saying that Werner von Braun, whose project was to go to the moon and back, and he succeeded, had some trouble with Newtonian mechanics, and he had to modify it so that when his satellites were rotating, they behaved properly, the way he wanted. He was not able to use Newtonian mechanics to carry out what he wanted his rockets to do, his the probes. And so if that's true, and I can't believe that I was being lied to, because there are other physicists like Eric Lathwaite or Alexander Dmitriev, who have argued that Newtonian mechanics is incorrect in general. And so anything based on conservation of angular momentum would be suspect then. If von Braun couldn't even use Newtonian mechanics to make his rocket payloads behave properly as far as rotation was concerned, then it seems to me to be an overstep to start talking about cosmology when you don't know what you're trying to go to the moon and you're not sure what mechanics you should use.
But were these claimed departures from Newtonian theory second order or small things, or were they?
All I know is that I was told that he had to have inserted a correction term. So I suppose that would be first order. And there's another one. I can't think of his name. Just a second. I'll look it up here real quickly.
Okay. So in a way, Vladimir, Denny is raising a similar point to the one Jim started with.
Yes, here it is.
That's that chap, that Gooch. Yes, I remember that. Yes.
Yeah, and he had videos illustrating his points with actual mechanical models that he built, but he apparently became short of cash and signed an agreement. And his books are still available. His videos the key ones have been taken down. This isn't unusual. Nick Percival, who was just talking, told me that he had a program for teachers, which would help them keep track of everything and so on. And he sold it to someone when he realized he wasn't having much of a life. He was spending all his time working on it and updating it and whatnot. And then they canceled the whole works and fired his son, who was working for him. So, and not only that, but Jeff Cook, who gave a talk a few weeks ago, was working with a scientist somewhere on the East Coast, I think it was. And he, all of a sudden, this guy disappeared. He looked for obituaries, everything. Apparently, he too had been bought off. And then everything he did was canceled, and any videos he had was taken down, and so on. And he was unable. He tried all different ways to locate this man, and he wasn't able to do it. So this sort of thing, there are people that go around and find entrepreneurs with ideas who are getting a little discouraged and offer them fairly good money, and with it's making them think that they'll continue on, and then they don't continue on. They cancel everything.
Okay, well, I think not many of us in this forum, I dare say, have been offered some inducement to cease our activities, but possibly because they're not going to lead to anything practical in the near term.
Well, it's anyone who has a working model. See, that's what they don't want. They want, you can write the theory if you want. These books, as far as I know, of Gottfried's Guski's are still available online. It's just the videos of the hardware that have disappeared.
Okay, so that, presumably, Denny, that's why they were rather upset with Lathwaite, because he was developing all these gyro.
Yes, they froze him out. They wouldn't talk to him. When they met him on the stairway, he'd say hello, and they would pretend they didn't hear.
Right.
Then, not only that, they alleged that he was in league with the devil.
Okay. Well, that's medieval stuff, you know.
No, well, a lot of people, I believe in the devil. I'm not medieval, but I mean, it was, so he finally ended up his life. He was working for the American government on a satellite, what do you call it? A rail gun satellite launcher.
Oh, yeah.
It was in a high mountain, and they were going to put a tunnel, and then the rail gun would accelerate the satellite launcher to the point where the thing would go into orbit. And that's what he was working on when he died.
So, Vladimir, I don't know, in view of Denny's points about non-conventional systems and other practical systems and being bought out, and, you know, maybe being contrary to the Newtonian conceptions and so on, would you have any general view on that insofar as it relates to the work that you've been doing over the past 25 years?
You know what? One person cannot develop principally new classical physics, everything from the beginning. That's why my main objective of the model is to give some ideas, conceptions, and then invite people to develop details of these conceptions. It's only basis for the new physics. That's it. That's why to ask one guy to develop everything what is done for hundreds of years, it's impossible. That's why even this planetary movement, it depends. There are some details of this. I talked about so-named non-gravitational accelerations and all this stuff. I know this about, but it's a totally different story. It's only one question for satellites, how to move them inside of our solar system. That's it. But I'm so happy they can do it. They can do these pictures of very far away, Pluto or some other planets with a very good resolution. I'm happy. How are they doing? Using Newtonian, or they use some additional equations? I don't know, and I'm happy with them. Simple like this.
Okay. Well, I'm pleased to give you a bit of a preview without going into detail, because it's a bit of a surprise and we haven't worked out the details yet. But Denny will be speaking to us actually on a number of occasions in the fairly soon.
8 weeks.
Okay. I'm always with you.
4 weeks.
I'm always with you guys. I will be more than happy to
with
presentation.
David Boyer, I think, yes. Okay. Well, thank you very much, Denny, for the present, for bringing up those points. Which
I'm sorry I have to be so negative, but I just can't honestly go with using antiquated physics to explain the cosmos. I mean, you have to draw the line somewhere.
Okay.
Yes. Okay. But on the other hand, many of us are extrapolating from well-known, at least to first order physics equations, and we're applying them to the cosmos. And in many respects, I think we're getting some successful results. most of us probably question very fundamentally the mainstream insofar as they're claiming that their results are also following from extrapolating physics. But that doesn't mean we haven't done it in some respects. And I'd like to know more about that von Braun business, by the way. I mean, were these
yes,
sort of...
I wish I'd have followed up on that. But since I had already studied Godfrey Guski's work and also the Boeing technology, that it didn't, it was just another log on the fire, so to speak. It was.
I'm sorry to be a bit skeptical.
I should have followed up on that.
A lot of things have been said. For example, it has been reported that von Braun said, actually, we had help from aliens or something. We couldn't have done it otherwise. Now, that seems I don't know, a fabrication, but one doesn't know. These stories come around. So thanks very much, Denny, for raising those points. I think
You're welcome. I'm sorry I couldn't be more positive.
No. We want all views, critical. Jim and you have raised some views which require us to think a little more. I think Jim may want to come back. I'm not sure. Let me just see. And Harry is here as well. So I'll bring you down now. I'm not sure. Were you signaling to come back, Jim, or were you just raising?
Yeah, I just wanted to say briefly that I think we have to look at what Denny was saying just now in terms of the sort of multi-power struggle going on Earth today among major nations. And I happen to be in the orbit of the United States. I'm a citizen of the United States, etc. And, I that scientists have to realize that technology can be used against the United States and its allies, and therefore there is possibly a quite good reason to block dissemination of technology, and theories, which could give opposing nations or power blocks on Earth an advantage. That's all I wanted to add. In other words, you might see it in this more general context. And in that sense, I don't think it's very sinister. It's something which is just what is in our situation in the world today. Thank you.
Well,
let's hear what Harry has to say, please.
Thank you. I'll bring you down now. Well, I think the fact that these extraneous points are being raised, I have to find you where you are to bring you down now, is an added bonus to what has come out of this lecture. Here we are, remove. Yeah, okay. We're going to have to end it now. I don't know if Harry wants to come in or not. We're okay. If you could be very brief, Harry, because we're running out of time. But what's your conception on some of these points?
Okay, I think this angular momentum argument is a red herring, and I think Vladimir did a pretty good job, but that's not really my main comment. My main comment on his presentation is that there's too much information, which I think is an issue. A lot of information and to absorb it all is very difficult. So my suggestion to Vladimir, I'm going to repeat it. I've suggested this many, many times, and that is he needs diagrams, he needs visual aids, and just having a presentation with words and a paper with words, and it needs a visual aids. And given the availability of artificial intelligence, one of the things where it's really successful, the large language models, not artificial intelligence, kind of a misnomer. The large language models that have been developed are very good at creating graphics. And so I would suggest to Vladimir that he work with somebody. I don't know that much about it. I know Roger Anderton is very much pro AI. Maybe Roger and he can get together to create some visual models of the overspinning volcanic eruptions and how the universe is galaxies and galaxy clusters are created. Perhaps an animation of that process would be very helpful.
So if I could issue an invitation, I mean, I don't think it would be unfortunate that we've listened to Vladimir giving us the complete spiel with all the paper and all the details. And maybe if I could ask him to consider coming back in the coming months, maybe with such a presentation, and you know, maybe he might ask for some help. I could even give him some pointers as well. So thank you very much for that,
Well,
Harry.
thank you so much for very good proposal, as usually. Harry, thank you very much.
I back it up, and I invite
moment.
you to come back. Yeah. So thank you, Harry, for that.
Thank you, Harry.
So, Vladimir, I'm going to, even though we're just running out of time this now, I'm going to give you a minute or two to summarize, and just if you want to add anything in view of what we've just said and we didn't have time to deal with in much detail, and then I'll come back and physically close the meeting. So
there is not so much to tell, only to thank you so much, guys, for your attention, for trying to understand my too much information in one presentation. I tried to do my best, but unfortunately, as usually, I've done too much. Thank you so much for everything, for interest in my model, for the questioning of it, and I will propose to think about, to develop my model as much as I can. Thank you.
Well, thank you very much, and it devolves upon me to close the meeting now and to say a word or two of appreciation to our speaker. I think actually it's a fortuitous criticism to say you've given too much information and you've gone into too much detail. It would be much worse if we said, oh, you have theories and you haven't told us what they're all about, and you haven't given us enough information. It's all there. As I said to Vladimir before we started the meeting, he's obviously a very prolific researcher. He's certainly much more prolific than I am. I tend to think a lot for maybe a long, long time, and then I produce something. I'm a bit, sometimes I claim merit. I'm a bit pretentious in sometimes quoting the, what a far greater man, perhaps, Gauss said. He said, what did he say about his writings? Porca sed matura, which means few but ripe. He wouldn't produce great amounts of information, but whatever he did produce was really ripe. It was a great merit. But Vladimir has produced a lot of information, and actually it would be worth people going in and maybe studying that. He's gone into great details in the cosmological aspects of it as well. And we actually look forward, if he does take up our invitation, the invitation which I've offered, which has been prompted by your comments, to come back and give us maybe a more diagrammatic presentation, you know, more concise on his theories at a later stage. We'd be very happy to have him back. So, everybody, thank you very, very much. Thank you for all the comments. The comments had come in mainly through Facebook, I see this time. And sorry, not Facebook, through YouTube, the opposite. I haven't seen them coming in through Facebook today, so I'm not sure about that. But you've all been very responsive, and thank you very much. Yeah, Shockwave just says, you know, what Harry has said, talk to Roger about interacting with AI. And even a person like me that doesn't use AI very much, I have actually summarized, I've put in papers or I've put in reports into AI. Maybe I had a 17-page report with a lot of information. I put it into AI and it gave me maybe 3 pages of summary, which I could concentrate my mind on. And I think had I pressed a few extra buttons, it would have given me graphs. So it's quite possible to do that. Okay. Okay. People just saying thanks. So thank you very much. Last but not least, as usual, to our speaker. Vladimir has gone to exceptional trouble to produce all this documentation, which is the result of his quarter of a century of work in fundamental physics, having regard all the time, as he continually expresses, to experimental results and not to mathematical fantasies, which can turn out to be, if they're unrelated to experiments, merely fantasies. So thank you very much, Vladimir. Thank you very much again for coming back and agreeing to give us a talk. And we'd like you to come back again, and certainly consider maybe giving a more concise and graphical presentation, not as an opposition to what you've given, but rather as a supplement to it. So thank you all very much again, and thank you for your comments, everybody in the green room. Thank you indeed. So I'm going to end the stream now and wish you all, I'll say, do svidaniya, and goodbye.